um, the last few chapters. So just going to do a recap of chapters 8 and 9. Then I'll stop the recording and just start a new recording. Then we will also focus on 10 and 11, so that we just cover everything for you. Then what I will also do is just put the few sessions that we had. I will just put all the presentations of that into one, create a PDF, and just send that to you guys as well when you have that, as well as a reference guide. Okay, so basically what we did in chapter 6 and 7 was looking at normal distributions. We went into a bit of sampling distributions, where we then looked at samples where we know what the standard deviations is, samples where we don't know, and then we also looked at samples of proportion. Study Unit 8 is basically taking that component a bit further. So we're looking at confidence intervals. So what we are looking at is confidence intervals around those samples. So the first one will be, again, confidence interval where we know what the standard deviation is. Confidence interval where we don't know what the standard deviation is, and then the confidence interval around the proportion. So basically moving from chapter 7, where we worked some of those things out, into chapter 8, where we now look at it more around the confidence interval around those measurements. And that is nearly what you guys will also then have in your exams, is the questions around that. But there's one or two other things. So in your study guide, there's this nice table that you can use. You're allowed to use it, again, open book. So for confidence intervals, we always look at the two-tail. The reason for that, just remember, two-tail is looking at, when we do the normal distribution, it's looking at both sides, and that's basically what the confidence interval is. So the mean is in the middle, and we get a mean plus a lower confidence limit, or lower confidence mean plus the upper confidence, and that is your two confidence limits. So then important is to know that when the standard deviation is known, so this one where it is known, we use the Z and we use the Z table, but in actual fact, we use these numbers. So you actually don't need to go to the Z table in your study guide. In the exam, it will only be a 90%, 95, and a 99. So you will not get 96% or anything like that. When standard deviation is unknown, then we start looking at the t distribution. Then for the t distribution, again, I will show you an example of that, but we will then look at how to work it out with the degrees of freedom, and then specifically how to use the t distribution table for that. And then the last one, when we look at proportion, and let's just quickly just want to do this because for this proportion, you're also going to use the Z. That again is reflected in the Z table. So again, you're allowed to use this for that. Okay, so that is nearly on the confidence interval. Sometimes, like we did in chapter 7, they might give you all the information in a question to work out confidence interval, but they might ask you to work out standard error because that is in this component, you get the standard error. The same if you in this one, where you can see you have the standard error. So they might ask you, even with confidence intervals, a standard error question. What they sometimes also might do is only ask you the lower limit or the upper limit. So it sometimes look different because you then don't see a lower and the upper. It's because they actually only want you to have one number. Okay, so that's a basic quick summary of those three. Then what we will do with that information is to take that information into study unit 9, where we look at hypothesis. So in hypothesis testing, you will then need to really say, if you look at, if you have it 2 points, is that number that you're looking for, is it in between those two confidence interval limits? So is your critical value, where is it lying? So is it lying within the area that you accept? Is it lying in the area that you don't accept? So that is nearly how we take the confidence intervals into the hypothesis testing, is to say that, do we actually accept or reject the null hypothesis? But again, when we get to that, we will go into that in a little bit more detail, because the question that they will ask around hypothesis is not just reject or accept. They will have that you need to work out the critical value. They might have that you work out the Z, the T, um, the area of acceptance. What else might they put in there? But we will get to that in a while. But that is just important nearly as how we've moved from confidence intervals into the hypothesis testing. Then with the hypothesis testing, I think what is, again, for me, how I look at it is that normally how I would look at it is I will write down, let's just get to, I would write down, if I don't give it to you, go to hypothesis. So that's the first two steps. Really write down what's the null hypothesis, what's the alternative hypothesis. Then you look for the level of significance. So I'll show you as we do an example around that. Level of significance and your confidence coefficient is basically, if you have the one, you've got the other one. So if they tell us it's a 5%, we can then say, well, the confidence coefficient is 1 minus that 5%. So those two are always linked. The same with your null hypothesis and alternative. If you have the null hypothesis, you automatically know what your alternative hypothesis will be. And when we go into that space where we say, okay, is it lying in the acceptance area, so we do not reject the null hypothesis, or is it lying outside of that spectrum? So we're looking at the acceptance region, and that is linked to this one. So if it's falling in the acceptance region, it's great. If it falls with outside of that, we reject the null hypothesis or whatever we've talked about. And then there's one or two other things that's important. We need to work out the critical value because that is what we're going to use. We need to find out if it is a one or two tail. But again, this you will see out of your null hypothesis if it is a one tail or a two tail. The only time it is two tail is when we have the equal and not equal. This is the only time when it is two tail. Okay, so all of the others will be a one tail test. Okay, so let's go into a few examples, and this one I want to do way at the end just to bring everything together again. Okay, so let's go into a few examples. So the first few is to look at confidence intervals. So there's a few things that we need to first identify. So firstly, are we working with a mean or are we working with a proportion? And then if we're working with a mean, is the standard deviation known or is it unknown, and is it a sample standard deviation? So that's nearly the first thing, because we want to know, are we going to use a Z? Are we going to use a T? Or are we going to use a Z? Okay, so let's read what they tell us. A household survey based on a sample of 50 households in a rural village found the average household income to be 3,000 Rand with a standard deviation of 900. Now conduct the 95% interval estimate for the population mean household income and choose correctly. Okay, so what would you guys have said? Am I working with a population mean or am I working with a sample mean? So is the standard deviation known or unknown? Okay, so if I look at this, I would have said, okay, sample. So I will probably have gone with your mean, your standard deviation is unknown. Okay, so is that, oof, what is going on here? So just quickly, there's something weird with my computer. I just want to quickly disconnect with you, and I will share it now. Then what happened here? Sorry about this. I just need to, seems like I need to just disconnect something. Um, the screen will be back now in a few moments. Sorry about this. Just get it sorted out. Press button. Okay, let's quickly see. Okay, can everybody see again? Hope so. Okay, cool. Okay, so let's look at this. They tell us 49 households. I would have gone for, because we're talking sample, that my standard deviation is unknown. So we would use yes. There's a hand. Yes, you can speak. Okay. If okay, it's weird. Maybe I don't know if there's issues with if you maybe type also in this, please, if you want to say something and the sound is off, you can also type in the message. Okay, so first of all, in the message type for me, which one would you use? Standard deviation known, standard deviation unknown. So is the standard deviation that of a sample? Is it the standard deviation of the population? So what would you guys, and you can put it in the chat. If this was a question in the exam, what way would you have gone with this? So you can just put in the chat a Z or a T. Would you have gone with a Z distribution, or would you have gone with the T distribution? So if this was now exam, what would you guys have done? Okay, because this is, I think, sometimes one where they catch us out nearly, or they want to catch us out. So we've got one that says T distribution, or typing. So probably would have gone with T. And the reason why I would have gone for the T is I talk about okay, see, so okay, so that and I think that is important. So I'm glad that is how you said the Z. You would have gone with Z because they tell us what the standard deviation is. Okay, so and that is where they want to catch you out. Okay, so they are talking about the sample and they're telling us the sample mean is 3000 and the sample standard deviation is 900. Okay, so even that you know what the standard deviation is, it's not the population standard deviation. Okay, so you don't know what the population standard deviation is. Okay, so what they gave us is the mean and the standard deviation of the sample. Okay, so and this is really one of those where they try to catch you out. Sometimes let's quickly look at one or two of the other questions. Here they say sample standard deviation. Let's quickly, okay, this is proportion. Okay, so yeah, so that's why I just wanted, and specifically why I included this question, because of that. Basically want to catch you out because yes, standard deviation, it's given, but it is of the sample. Okay, so that is why it is a bit different and why they want to catch us out with that. Okay, so now we need to get degrees of freedom because it's the T. The degrees of freedom is 50 minus 1, so it is 49. And it's always alpha divided by 2. So degrees of freedom is 49, and alpha divided by 2 is 5% divided by 2. So 0.05 divided by 2 is 0.025. So that we will get from the T table. So let's just quickly see the other ones. We've got the 900. We've got N is 50. So let's quickly check. I must just quickly open my table. And again, you guys are allowed to use your study guides. And what I would do again, if since we are working with Iris again, and when you might now work in the exam and now suddenly you realize you need to open your study guide. As you write in Iris, tell the computer nearly, tell Iris, I am opening my study guide because I want to get to the T table. So that it nearly, if it flags you for that incident, then at least you told it what you are doing. I think that is sometimes because we've seen that Iris really, unfortunately, it does give us a lot of headaches. But I would just, as you write, and you now see, okay, I need to open the T table, tell it. I am now opening the T table because I need to get a value. Okay, so let's quickly see degrees of freedom. What was it? 49, 0,025, 2,0096, 2,0016. So let's just see if we get that. So again, I need to do a few calculations with my calculator. So I'll first do the 50 square root. If you got better calculators, say 900 divided by the square root of 50. Mine, I need to do a few brackets and things like that. So when I work this out, okay, let me just quickly see, I get 255.8. Okay, so then it will, oof, sorry, that's terrible handwriting. So at the top, it will be 3,255.8 or 3,255.8. And at the bottom, it will be 2,744.2. And I just now rounded it off to two decimals, but yeah, so that will be your answer. Yes, so because you could not, and just responding to the chat, you can open the PDFs, so your tables, your study guides, you're allowed to open. 1610 is also, you're allowed to open Excel, but it needs to be a clean Excel spreadsheet. Can't have the formulas and those things in. But again, what I would do is when I open Excel again, I will just tell it, I'm now opening Excel. I was told I'm allowed to do it and then you can work with the calculations within Excel. So again, because what we've realized is with Iris, it flags, and then it doesn't always know what the student is doing. So just tell it straight on, this is what I'm doing. 1510, please don't, you last time still, this time still around, you're not allowed to use Excel. But again, your study material is your study material as long as it's in PDF. You open it in PDF. Don't open it in a new browser window or anything like that. If it's in PDF, you are allowed to open it. Okay, so then I thought this one I definitely have put in last time as well. And it's just nearly to see how the T distribution works. So if you look at, and let's quickly just, if I can clean this. So if you look at this T distribution, it's very similar to the same as your Z. It looks very normal. There's your T value like it would be a Z value. On this side, you've got alpha. On the other side, you've got alpha as well. So your T distribution very similar in a sense. So also on your T distribution, let's just see where can I quickly, right? Okay, so on this side, you will have a negative T. On this side, you will have a positive T. That will be alpha, that side, alpha. So just important nearly to look at it from that point. Okay, so in a sense, very similar to the Z value. So you would also see if you go to the infinity, or even if you look at degrees of freedom of 120. So if you look at your sample size, when it becomes bigger, it actually becomes the normal distribution. Okay, so it becomes the Z value. So if you sit with a big sample of, say, 250, it's not even big enough here. So if you say 120 even sample size, you're actually working with numbers that are the same as the Z table. But back to the question. So let's quickly look at a few things. So a T value associated with a lower tail probability of 0.01. Okay, so let's look at lower tail 0.01, and did they tell us what? Okay, obviously what I am missing here is, oh, okay, we don't have, okay, so I need to have the degrees of freedom here because all the sample size. Okay, so somewhere that has dropped off. So let's quickly see if I can remember if it was 19 or 18 or something like that. So let's quickly check. 182103. Okay, no, so then it was, okay, but something else. But this is frustrating. I will check if I have it somewhere else. But how we do this is you need to have a degrees of freedom. Then you would take the degrees of freedom, go across where it is the 0,01. Then you will need to add, so let's do it the other way around. 2,473. 2,473. Okay, so it was degrees of freedom of 2027. So the degrees of freedom was 27. We can test it with this one as well. So 0,01, 0,01, 27, just a bit, 27, and then it would have been 2,473, which would have made it correct. Remember negative because they told us lower tail. Upper tail would just then be positive 2,473. Let's look at the 0,025. 0,025. So there we have it. 0,025. Positive 2.052. 2.052. Negative is minus 2.052. So that one is also correct. If we had 0,001 and we set upper tail, then we would have looked at degrees of freedom 27, 0,001. So let's look. Come on, isn't there 0,001? Okay, so let's say 0,05 rather. 0,05 upper with 27, 0,05 upper 27 will give us 1,703. So it will be a positive 1,703. Okay, so that is when you're looking at the degrees of freedom and you need to get the t value. I think there was nearly something like this in the exam in last year. Let's just look at one of the others. So where you basically are looking at an area, here they say 95% of the area under the T. So here is 95%, and you can do that with a 90 and for 80%. So if this is 95%, this area plus that area will be equal to 5%, so that we can get the total of 5 plus 95 is 100. So each of these areas is actually 5% divided by 2. And so this green area is actually 2,5%. So it's 0,025. So I'm looking for the t value at degrees of freedom 27, 0,025. 27 0,025, 2,052, 2,052. So that one is incorrect because we wanted here to have it as 2,052. And on this side, minus 2,052. And then you can actually go and practice DE. You can look at, so there is a 90, but remember, you need to divide by 2, so don't go straight to that. Make 100% sure of what you are looking for and need to get. Okay, so again, important when you read the table that please take this into consideration so that if I say degrees of freedom with the 95, 90, or 80, that those numbers are always the numbers that are between the two limits. Okay, so that you don't look at it there as a 95, go to 95, and then you get a different answer because you're actually looking at the other one. And that might also be where some of the mistakes was made in the exam. Okay, still confidence intervals. This one, simple random sample of size 19. So we is becoming smaller and smaller. So 19, let's look at if it is Z or a T. So let's look at standard deviation, known or unknown. A simple random sample, normal distribution. Again, now I say sample mean, sample standard deviation. Okay, so sample standard deviation is that. So we don't know what the population standard deviation is because we don't know what the population standard deviation is. We are going to work with a T. Okay, so degrees of freedom is 19 minus 1. Confidence interval that we are working with. So alpha is equal to 5% because it's 100 minus 95. So the T that we're looking for, degrees of freedom of 18, and then the 0,05 divided by 2. And so that will be the T that we're looking for. And then your formula is as it would have been if it was the same with a Z. It's your mean plus minus T times standard deviation divided by the square root of n. Okay, so the sample mean we have as 200. The T we will need to work out. Standard deviation is 50. Sample mean is 200. Okay, so let's look at the T18, and then again it is 0,025. 18, 0,05, 0,025. So there we have it as 2,1009. Okay. What is different in just want to check. Okay, so the Z, the T was a bit different. It feels weird. Okay, but let's quickly work it out. So square root of 200, I now need to work it differently again. So 50 divided by square root of 200 is 3,53 times 2.1009. So I get, there's definitely, I made a mistake. Let me quickly just check. 18, 0,0 is 2,1009. Just again check. Other component. This is definitely not working out. I must have made a, where have I made a mistake? This is definitely not. Size 19, so degrees of freedom is 18. Sample mean is 200. Ugh. Okay. N is not 200. It is 19. So, stupid, silly mistake there. Luckily, there wasn't an answer for that, but sure. Okay. Brain is not functioning in this heat. Let's quickly try again. 50 divided by the square root of 19. That now makes more sense. Much better. 24.10. So the top is 224.10. The bottom number will be 175.9. So let's see. 175.922. Okay, so silly mistake. And only after I'd done it a few times I realized I made the mistake with the N. N was 19 and not 200. The 200 was the sample mean. So please, even those small things that one can make a mistake on. Luckily, there wasn't one of those was an answer for that mistake. Okay, but important thing here, again, the sample. So when we look at sample tells us that we will need to work with the t distribution. Then to get that t value, we will need to go to the t table. Okay, so then hopefully one with proportions. So let's quickly see. Most of the schools reported a decline in the number of absentees in a sample of 90. Let me write it down that I don't do that again. 72 schools reported a decline. Okay, so 72 divided by 90 will be your proportion. So 72 divided by 90 is 0,8. So that will be your proportion that you're working with. 95%, because it's proportion, we know that we are looking and working with a Z. Because it's 95%, we can work with a Z of 1,96. So when we do this formula, we can work with that automatically as a 1,96. So let's just see 0.8 plus minus 1,96. And just again, why 1,96? Getting it from the original table in your study guide, where it says, if I'm working with a 95% confidence interval, I can work with 1,96. So straight from that table within your study guide. Okay, then let's divide it by, let's just now make sure that we're working with the right n again, 90. So 0.8 times 0.2 divided by 90, square root of that times 1,96. So what that will give us is 0.8 plus minus 0,0826. We can probably round off at some point. So if I add it, the top one will be 0.8 plus that. So at the top, we'll sit with 0,8826. So let's just look 0.828, 0,86, 0,88883. So that will be rounded off to 0,883. Okay, very easy to have made that mistake as well of 0.828, just because you see all the numbers for 8 and for 2. So sometimes very easy to make that mistake as well, just because your eye catches numbers. Yeah, so what I will also do in an instance like this is just check the bottom number as well, because that now would have clearly been 0,717 and not 0,692. So it's not that they have given you here also 0,717 and try to catch you out with a number there. Okay, so that is the confidence intervals. Then from confidence interval, we go into hypothesis testing. So again, here they give you the hypothesis. So you can see, firstly, smaller, equal, and the other one is bigger. So if we see that we're working with a one tail. Okay, so if I'm looking at this, and more applicable one tail where it is the lower end or lower tail. So let's look at what do they tell us here. An upper tail Z test is applicable. Okay, so that is just totally incorrect. It is a Z test because the population standard deviation is known. So that gives us the Z, but it's not upper, it is lower. Okay, because we are looking at the lower end. So it's not the upper tail. So let's just quickly write this out and see if there's one or other things that we can pick up. So we would have done the Z. The mean is, this is interesting. Let's just rethink. Let's just rethink this one. Because I wanted to say that because that's smaller. Let's just check what is happening here. So smaller or equal to, and we need standard deviation divided by. Okay, and that is smaller or equal to x is 84 minus 80 divided by standard deviation, which is 16, sample size of 84. So that is going to be 0. So that is from chapter 6 and 7. Let's look at what is this value. 84 minus 80. So that gives us 4 at the top. So it's going to be a positive number. 16 divided by square root 84. 1,7457 is what I get. I will just check it again, but 4 divided by that. It 2,29. And so let's just see what it again, sorry, I made a mistake again. I always, so please don't do this in an exam. Sample size is 56. I'm not too want to hurry things. So write down, and I didn't do that. So what I normally would do is write all of these numbers down that I am using, but I don't make the mistake. So if you write it down, you will put it in. So again, silly mistake. So let's see, what is 16 divided by square root of 36? 2,6667. So please don't make these silly mistakes when you're writing. Second time, I'm doing exactly the same by actually looking at the mean instead of the n. Okay, so Z value is 1,5, but Z value of smaller, so we're going to work out that component. Okay, so that is not a upper tail, that is the lower tail. And so that is why that one is incorrect. I just wanted to show you guys again. Test statistic is 1,5. So if you go to the Z table of 1,5, let's go Z table let's go to the negative 1,5, 0,0668. Okay, so that also now, so it feels like there was more to this question. That is also wrong, because that p-value, even if you look at the 1.5, it's going to be the 0,06. So that's also wrong. Okay, so here was a few in this one that was wrong. So what I think was probably with this one was pick the ones that, because I say statements, so it might have been that they would have said B, C, and E, or A, C, and D is wrong, or just A, or just E, and then, but this is definitely both of them are wrong. That would have needed to be the other way around. So I'm going to actually delete this slide from the spec, that you guys don't need to worry about this. If you guys see something like this in the exam, again, please let me know, so that we can sort it out, because those things are not great if you are sitting in an exam and there's one or two things that are wrong. So please, if you see something like that in the exam, let me know. If you pick up, I will again let the lecturer know if there's anything that is wrong with the questions. Okay, let's quickly look at something different. Suppose that the calculated t-stat for a lower side, lower level test is 2 or minus 2,82. Minus 2,82. They tell us lower tail. What else do they tell us? Population standard deviation is known. And if it is known, it is a Z. When they ask us what is this p-value, okay, so we only want to get to that smaller part. They told us it's one-sided, it's not two-sided, so we only want to know what is this probability sitting here. Okay, so Z, we go to the Z table of minus 2.82, minus 2.82, 2.8, 2.8, where is it, 2.82, so 0,002, 0,002. And so there is the 0,0024. It might have been now for some of you guys, because again, just like in the exam, you might get different version of a question. If they said two tail, the only thing that you need to remember with two tail is when take the p-value and multiply it by 2, to take that 0,0024 multiplied by 2, then there is the 0,0048. So that would have been for the two-tail. And so just so that you guys can see how it would have been done if they give you exactly the same information, just telling you it's a two-tail, then that is how it would have been done. Okay, so now one more question, and here we talk a lot, just words. So let's first look at everything. So we reject the null hypothesis and conclude that grade 6 average reading speed is less than. We reject null hypothesis. So let's just quickly write that again. Null hypothesis conclude that grade 6 average reading speed is not significantly different. So that is not significantly different. So we don't know if it's less or if it is more. We do not reject is less. We do not reject not significant. There's not enough information. Okay, so let's read. So various literature groups recommend a reading speed of 177 words per minute for grade 6 learners. Grade 6 teacher is convinced that the average reading speed for her class is less than. Okay, so what she's saying is she's convinced it's less than 177. Then now they say you are required with all of that information to make a conclusion. Okay, so the first thing that we will now then see is, without looking at the rest of information now to work it out, B and D is going to be incorrect because we are looking for the less than. So it's only A and C that is talking the same language as what we have in the question. B and D is talking about it's not significant. We're not looking at it from a not significant. We want to get to less. So less than. So again, just by reading the question, not working out if you time pressured in the exam, you basically could have eliminated two options. It will not be not enough information. So if you need to guess, you guess out of two and not out of 5 options or 4 options. Okay, so let's look at the rest of the information. In a sample of 35 grade 6 learners, the average reading speed is 168. We're going to have 168 minus 177. With a standard deviation of 28. 28 divided by the sample size of 35. Now, the only thing that we need to tell is this Z or the T that we are working with. Okay, so various grade 6 teacher is convinced that the average reading speed for a class in a sample of 35 grade 6 learners, the average reading speed is that with a standard deviation. Okay, so sample with standard deviation. So we're working with a T. So we basically want to find out what is the T and then compare that with the 1% or compare that to see if we accept, reject the null hypothesis. Okay, so 168 minus 177 is minus 9. So that already make it working on the negative side, but that's fine. 28 divided by the square root of 35, I get it 4,7329. I hope it is correct. So I get it as, in the end, it's going to be negative 1,90. Okay, so basically, let's just quickly, just want to draw this over. So let me just take this out. There's not for me enough space here. Just want to move all of these things. Just want to move that into there so that I just can draw it a much clearer picture. Let's do that. Cool. Okay, so that is 0. Here we have a minus 1,9. They tell us that we're looking at the 1%, 1% sample of 35, so degrees of freedom is 34. 1%, so 1% is 0.01. So that divided by 2 is 34, and we're looking at 0,005. So let's go t-table 34, 0,005. 2,7, wait, that'd be 34, 2,7284. It sounds very big, but so sorry, minus 2, let's just say 74. Okay, so the T that we worked out is lying within that area, so that's why I wanted us to come back to where was that slide. So the T is lying in this area where we do not reject the null hypothesis. So do not reject the null hypothesis. Because it's lying inside. So we do not reject the null hypothesis and conclude that for grade 6 average reading speed is less than 1,77. Okay, so that is nearly how we would work out a question like this. And that's why I like, again, this slide. So what I will do for you guys tonight is let me just write it down. So I will create a, a summary PDF with only the notes, and then a PDF with all the things that we've gone through the last few sessions. That you just have both of that in a PDF so that you can use it. Because the last slide of this, again, is what I've added here is if you guys don't want to use a graph or something like that, just that you see the t-stat and the critical value, how that is also used. So I will put this in a PDF for you guys and share later tonight. So after the session, I'll download the recordings, put that onto YouTube, send you guys the link. And then what I will do is just combine some of these and send that into a PDF that you just have everything. I think it is just easier to have everything in one pack than all of it scattered into different packs. Okay, so let's look at the last two study units, study unit 10 and 11. Again, I think what is important here is in study unit 10, we're looking at chi-square. Basically, chi-square, the important things that you need to be able to do is what's in this table. Okay, you would have in your assignments and things like that, would have worked out a lot of things, but again, for the 1510 that don't have or not allowed to use Excel, they are not going to ask you in the exam to, let's quickly see, to work out the t-stat if they don't give you this information. They will not just give you this raw data and then ask you to work out that. The same with the 1610. They will not give you this without what the observed and the expected is. This already feels to me like something that they probably will not ask because it takes a lot of time. But if they do, I'll show you on here how we will do it. I'm not going to show Excel, but again, so what is important is that you need to know the null hypothesis and the alternative. The null hypothesis is always the independent. The alternative hypothesis is independent. Sorry, not independent, or they sometimes throw in the words of dependent. So just again, they might use those two words. So sometimes, again, the brain is focused that we're looking for the not, and then they actually just say dependent and one misses it. So just be careful around that. One is independent, the other one is not independent, but this the same word for not independent is basically dependent. How to get the degrees of freedom? Again, I love to ask this. I think it was in the previous exam as well. What they most likely will ask for you is to work out the expected value. This normally they will give to you with a percentage of confidence to say use the table and do you accept or reject. Okay, so let's go through a few exercises or a few examples. First one is purely a theoretical, but it references nearly a lot of things that was on this table. So and again, it's open book, you're allowed in your study guide, this table is a copy out of your study guide. So it's not anything different from what you guys have access to. So again, not the issue if you use it. Okay, so let's look at what they asking. The test statistic as R minus 1, C minus 1 degrees of freedom, where R is the number of rows, C is the number of columns. Correct. The observed frequency for each cell is equal to row times column divided by n, row times column divided by n, but it's not observed that is worked out like that. It is the expected. Okay, so again, one can very easily make that mistake because you like row times column, right, divided by n. Oh yes, correct. But actually, this is referring to observed. That part is actually the expected. So again, I try to catch you out with something like that. Then chi-square is always used for two variables, for two qualitative variables. So that is correct. And qualitative variables, think about it as by asking you in what province you stay and if you're smoking. So that cross tab can be, I'm staying in Gauteng and I'm a smoker. I'm staying in Western Cape, I'm not a smoker, or it can be levels of smoking or anything like that. So it is about qualitative, so it is not quantitative where it is counting numbers. This is basically dividing it into that cells that you have in a cross tab. The null hypothesis is that of two variables that are independent. Correct. The alternative is not independent. So if I have R squared, that is the null hypothesis and the alternative. And if I observed and the expected frequency for each cell are equal, then the t-stat will be equal to 0. And so basically, if I observed and expected are equal, that means that if I subtract the two, it will be equal to 0. So if I had a 2 by 2 table where that is 0, that is 0, that is 0, that is 0, well, if I sum 4 zeros, that will just be equal to 0. Okay, so if your observed and your expected are exactly the same for each of these cells, you will get, say this was 23, so 23 minus 23 will give you 0. So even if it is divided by 100, it stays 0. So 0, 0, 0, 0. If you add 4 zeros, it will stay 0. Okay, so that is nearly how we got to that test statistic that's calculated as 0. And degrees of freedom, we saw the formula is row minus 1, column minus 1. So let's see, in a contingency table with 9 rows, 9 minus 1, 8. 2 columns, 2 minus 1 is going to be 1. So 8 times 1 is 8. Where is option C? If you did it differently to say 9 times 2, where is the answer? If you said 9 times 2 minus 1, there's the answer. If you said 9 minus 2, there's also an answer. So if you use the formula wrong, there might be different answers that you might actually select as well. So again, just be very careful. You have the formula. You don't need to guess. So degrees of freedom for chi-square, r minus 1, c minus 1. Don't need to have it memorized. You are allowed to use again the papers so that you don't get it wrong. Okay, so now they use that same information. So we've worked out the degrees of freedom. It was 9 minus 1 is 8. 2 minus 1 is 1. So degrees of freedom was 8. Level of significance is 1%. So let's look at what is that chi-square value. Okay, so let's look at where is chi-square. We're looking at 8. It's that we're looking at 8. 0, or what was it? 1%. 1% is 0.1. So we're looking at that component 0.1 and 8. 13.362. 13. Oh, 8. Why is that now? Ah, 1%, 0.01. What did I look at? 0.1. Silly mistakes. Please don't. So please, when you're writing, please be fresh. Have a good night's sleep before you're writing. Don't. Hopefully it's cooler in the Cape. 0.01, 8, 20.09, 20.09. Okay, so again, I tried now to get to shortcuts. So 1%, write it out 1/100, or put in as 1% on your calculator to get to 0.01. So your chi-square number is 20.090. Once again, I was lucky that at 1%, that number was not there. Else I would have picked 1%. I would have been wrong. Sorry, 0, one, I would not have realized why, but I actually was looking first where that is actually 10%. So stupid mistake, would have gotten probably 0 for this question. And this is supposed to be a easy question with easy marks, but very easily one can make a silly mistake. Okay, so just be careful when you guys are writing not to make mistakes I had been making today. Okay, so if you need to work out the t-stat, the formula is the observed minus the expected. So here they tell us you get the observed frequencies and the expected frequencies is in brackets. So what you will need to do is to say 55 minus 42,54 to the power of 2 divided by the expected, which is 42,54. Okay, then we will need to do it for the next one, which is 40 minus 45.89 to the power of 2 divided by 45.89. Then you need to do it for that one, that, and that. So again, more likely in the exam, if you get a question like this, it will only be for 4 numbers and not 6 numbers. But if you need to do it, this is how you would have calculated it out. So what I will probably do, so there's no shortcuts in the exam. If you get something like this, because once again, I'm like, sure, between those 5 options, it could be everything. So anything. So I would work out this first one, where it is 55 minus 42.54, that to the power of 2 divided by 42.54. So I see that first one is already 3,6495, and that's if I have calculated it correctly. So if I look at something like this, where that's the biggest gap, that's small, that's smaller, there's a big gap. So I will probably look at those two, get roughly an answer, but this already tells me, okay, with that first one, it's not A or B, but now you see, okay, sure, C and D is very close, probably also not going to be E. But again, if it's one of those two, you will need to work out all of these calculations. So unfortunately, not a shortcut. If you work it out, the right answer is actually option D. But once again, you will need to work it out for all 6 of them. But in your exam, if I ask something like that, it will probably be only looking at a 2 by 2 and not a 2 by 3, that you need to do so many calculations. But more likely, they will ask something like this, and they will more likely ask something like this, where you need to work out the expected value. And I hope, okay, the other thing that they can also ask is around putting in both the null hypothesis, alternative hypothesis, give you the t-stat, give you the degrees of freedom so that you can work out a critical value and then say you will reject or not reject. And then the process of that will be exactly the same as with your hypothesis testing, where you look at a diagram and decide on it. If it lies within, you accept. If it lies without, you reject it. So if you get a question like that, and now this is not, it's more something like that. But again, if it lies within, you will not reject the null hypothesis, so you will accept the null hypothesis, just like we did with the hypothesis testing of a T or a Z. If it is outside, you will reject the null hypothesis. Okay, so exactly the same. So it might be that there are something like this, but let's consider the continuity table below to test independence. What is the expected frequency of high school traveling between 3 and 6 kilometers? So it's basically high school and 3 and 6 kilometers. So we want to check what is that expected frequency going to be. So row total times column total divided by n. So let's look. Okay, they don't give us the n, they don't give us the r, they don't give us the c, so we will need to calculate a few. So row total 75 plus 120 plus 165. So that is 360. Column 210 plus 120, that is 350. Let's just check how much was the total. 115 plus 210 plus 315. 40, so in total it was 1,000. So that will be your expected value. So 360 times 350 divided by 1,000 is 118.8. So we round it off to 119. Okay, so that is your expected frequency. That is your expected frequency. Just be very careful again. So there's all numbers, but look at this. So if you set 119 divided by 1,000, you would get 0.12. And remember in study unit, what was it, 2 and 3, where we looked at the tables, we set frequency. Then if you took your frequency divided by the sample, you got your relative frequency. So just again, be careful what they are. So expected frequency is the number, but if I said relative frequency, we would have said and needed to say 119 divided by 1,000, get the 0.12. So again, just be careful for those wording, because frequency perfect, it is the number. If I said relative frequency, you might have still gone for the 119, got it wrong, and didn't know why, but it was when, because in study unit 2, when we look at that cumulative frequency table, that is where they suddenly brought in this term again. So just be very careful around that. Okay, when we go into the last study unit 11, around regression. So what again is important around the regression is that, again, 1510 guys, you not you can't use Excel, so a lot of the questions will be focused on interpretation, and less so on going to work out all the details. So less likely for both 1510 and 1610 that now suddenly they're gonna give you the data of X, the data of Y, and expecting you to work out everything. So just on that. Okay, so let's look at a lot of it, definitions, interpretations, reading speed estimate, regression equation of learners at a school, reading speed 13.1 times age plus a constant with a correlation coefficient of 0.686. Okay, so correlation coefficient that they give us is R. So let's look at 17-year-old learner is expected to have a reading speed of that. There's a moderate positive linear relationship between learners' reading speed and age. So that A, we need to work out. B, we read from the information. So your correlation coefficient is positive. It is linear. So that is correct. Because it's positive, a year increase will increase the reading speed. So, and you can see it's also linked to that slope. So because it's positive, it will increase. So that is because it's positive. If it was negative, your correlation would also be negative. Then a year decrease in a learner's age decreases reading speed. So that is how it would have read. The 13.1 is basically the slope. So with each extra years old, the reading speed is supposed to increase by 13.1 words. Okay. Then let's look at D. 47.1% of the total variation. Okay, this we also need to work out, because total variation is equal to R squared. we've got R, we don't have R square, so we will need to work it out. So let's look at the first one, because that we still need to work out as well. So we want to work out what's the reading speed. The reading speed is 13.1 times age, which is 17, plus 61.9. Let's check. 13.1 times 17 is 226, plus 61.9. So this answer will be 284.6 and not 298. So that will be incorrect one. Then if we want to get to the total variation, 0.686 to the power of 2. Power of 2 gives us 0.4766. If we want it in a percentage, multiplied by 100, and we will get 47.1%. Okay, which is also the D, the variation. So in this one, they're basically giving you all the information that's needed to calculate it. Okay, so here they ask us to work out so they give us consider the observed and predicted reading speed, use the given information to calculate the sum of square due to the error, and choose the correct answer. So here they actually wanted us to work out what is the x minus the predicted. You needed to square root that and then do the sum of it. So again, this was in, I think, the assignment and in the mock exam, but again, you will not get this in the exam. So you can go and test it. The option should be D. How you will work it out is 178 minus 180.36. That to a power of 2. And now you need to do it for all of them. So again, if you look at this, it is a lot of work. They will not ask you, and how much is about 10, I think. 1, 2, 3, 4. So it's 10 calculations of that. Need to add everything. So to do 11 calculations will not happen. So they will, if they ask something again like this, it will be 4 or 5 that you can, not want to say very easily, but it's much more manageable than a big list. So they're not going to test to see if you now make an error in subtracting somewhere. They just want you to get understanding if you can do what's needed. So if you know what the sum of squares due to error is, so that's nearly what they want to get out of it. So they're not gonna ask you this long thing. If it was 1610 and you needed to do this, I would put it in Excel and then work it out. That Excel does the calculation for me by saying 178 minus that to the power of 2, the next one to the power of 2, and calculate it out like that. Yeah, so what more important is for me is that they might just give you SSE and give you a few formulas. Ask you, what is the sum of squared due to error? So that is more something that they might ask, or they might give you. Now I need to remember. Let me quickly, I just want to go back to that study unit 11. Ooh, let me quickly just want to look at something for you guys. Study unit 11, and I might even share. So they might even give you, so I'm going to share this with you guys again. I know I shared it previously, so that they might ask you and list, where was it? Sorry, let me add this into that presentation. They might give you a few of these and say which one is right, which one is wrong. So instead of asking you to work something out, they might give a few formulas and say, select which is correct and incorrect. So let me just, while we are doing this, I see it's a PowerPoint, but that's fine. Oh, not a PowerPoint, a PDF. So let me just quickly take it off screen. I just want to take snippets of it so that I can quickly put it in this deck so that I will, when I send it to you guys, I will just make it bigger and fit it in. I just want to make now 100% sure that, so that you guys have it. It was on one of the old presentations that I did earlier last year, so that you just have it to go with as well. Instead of working out that big sum of things, they might just ask it a bit simpler. Okay, let's then go into a bit more. So here, let's put these questions together, or we can just do it after one another. But here you guys can see from previous exam papers. So they looked at considering two variables. It was, so let's cut it, put it here, so that you can see how similar some of these questions was for the two exams. This was still before COVID. Okay, consider two variables, exactly the same, where the one is on y is equal to 1,125, exactly the same, 0,375. The incorrect one, incorrect one. The independent variable, the dependent variable. Okay, so x is your independent variable, y is your dependent, and that is also, I've added it now here for you guys as well in that set those two slides. So independent is x, dependent is y. So, and why do we say it's like that? So if x goes up by 1, y is dependent on that change. Okay, so as x changes, y will change. So y is dependent on whatever happens with x. Okay, x, let's make an example again. So if you look at the reading speed, that is y. So the reading speed is changing as age is changing. So as x is changing, y is changing. So the thing that impacts reading speed is age. So the thing that impacts the y is the x. So that's why the y is always dependent on x, because y will be whatever x changes to, y will change to that. The slope is 0,375. The thing in front of the x is the slope, 3,75, correct. Here, the incorrect one would have been the 1,1235, because that is not the slope, it is the intercept. Now, there is a relationship between x and y. Yes, there is. What we could have added to it, because that is positive, it means that there's a positive relationship between the two. Because we don't know what R is, we can't say it's a strong relationship, it's a weak relationship. All that we can say is because the slope is plus, we know it's a positive relationship. For no relationship, R would have been 0. For no relationship, the slope will be equal to 0 or very close to 0. Okay, so, but that's not part of this. But so, because slope is positive, there is a positive relationship. If the slope was negative, there would have still been a relationship. The relationship would just have been negative. And when I say the estimated, so there, that question was also there's a relationship, correct. When I say the estimated value of y when x is 0, y when x is equal to 0, and so that 0,375 times 0 is 0. 1,125 plus 0 is equal to 1,125. There, that is incorrect, but in this instance, that would have been correct. So just again, showing you in this one from 2 different papers. So again, this is something that how they will give, because all the papers I think have 2 or 3 question options. So this is more likely to be one of the question options and a second one of the question options. You get exactly the same, but they just swap a bit of the information around that you can't really tell anybody else that for this question you WhatsApp to say this is what you got, because it might be just different for somebody else. Okay, so I just added these to that, but I will create the extra slide pack for you guys. Okay, so that was very quick tonight. I'm going through 8, 9, 10, and 11. For both 15, 10, so let's just stop sharing and um, give you a bit of other information. So the lecturer said you will put in a mock exam again. For both 1510 and 1610, it might be exactly the same mock exam that was run in last year, but there will be a mock exam. And there will also be communications around Iris again and just the steps to do that. But I will also quickly share some of those documents again on our WhatsApp group a bit later as well, that you just have that once again. Okay, everyone, it feels this was very quick today, but really good luck with your sub exams. I hope it goes really well, that you guys pass all of it. Now it will go great with you. So yeah, good luck. Just get in some rest the night before you guys are writing, so that it so that you don't make mistakes that I did today. Simple mistakes.